Anton, welcome back. So we've taken a couple of weeks off here. You've been heads down sprinting on the release of Stable Attribution, which came out earlier this week to a ton of fanfare. The last I looked, there were 6,000 something likes on the tweet. Obviously, a bit of controversy. Anything that gets popular on the internet does that as well, and particularly in these kinds of areas. And we'll get into that. But how's it been? What is Stable Attribution? We've been teasing it for a while.
Stable Attribution is something that Chroma, Jeff, and I started work on just before Christmas, where initially I had a lot of misconceptions about first of all, the objection of creators to, Stable Diffusion, to Midjourney, DALL-E. I like honestly kind of didn't get it because I had certain assumptions around how these models were actually made, where the data came from. And then I looked into it in more depth and I started actually investigating it because I was like, well, something doesn't really square here. Started talking to people and it was pretty clear that their objection wasn't like, for most people at least, it wasn't like, oh, these models are like threatening my livelihood, they're going to replace me as an artist. It was more like, first of all, like a shocking development in their own right. I didn't know that this was possible. And I think that that's, fairly standard. Most people had that reaction when Stable Diffusion and DALL-E and stuff came out. Yeah, right. Like it's pretty amazing. And then to have that shock then doubled with like, wait a minute, you used like my art to make this without really asking me, let alone, forget even the compensation piece right now. You used my art without ever asking for my consent. And I definitely didn't put it up on the web for this purpose because nobody knew that it could be used for this purpose a few years ago when I put up my stuff. Made a lot of people like honestly like shocked. And when you have like that double thing pile on, it makes people extremely defensive. It makes them think about what they stand to lose more than what they stand to gain.
Yeah.
And so that's what happened. And I was following discourse and I thought to myself, okay, well, that's interesting. This is a question about how much can we attribute to the training data of latent diffusion models, of which Stable Diffusion is a version, like we talked about in a previous episode. And I thought, okay, well, what is the first approach that I would try here? And we basically started development on that track. And we based our initial approaches off of publicly available open source software. We can get into details in a minute, but happy to answer more sort of questions around what's going on and how things are.
So you tried the first approach. Is that the one that you ended up going with? How have you refined it over time? What's like the final approach to Stable Attribution look like?
So I don't think that we're anywhere near the final solution yet. There are ideas we've played with. Some of them are deployed in the public version. We find that because we're pretty compute limited, we can't really have all of them stood up all the time. But there's a lot that you can do with the internal structure of how diffusion models actually work. There's a lot of like other empirical research and questions to be run here. And there's been, some papers recently that kind of demonstrate that these models, under what conditions these models actually reproduce their input. So I don't think we're anywhere close to it, but going from vanilla like semantic search in latent space, we basically tried to add more of what the model is actually doing on top of that idea of finding neighbors in this latent space. So we basically, doing straight like similarity search in a given latent space is fine, but the structure of that latent space isn't actually imposed by the diffusion process. You need to take the diffusion process into account, and you need to take the characteristics of the data set also into account. And so one of the very first things we did was to just look at duplication in the data set. So the original process was very, very straightforward. It was, take a Stable Diffusion generated image, encode it using the same encoding scheme, look for neighbors in the training set. Right. This is like the basic first alpha idea, that literally the first thing I could think of. And the reason that we chose to do that is because the training objective of latent diffusion models is to reconstruct the input latent or denoised versions at each time step of the input latent. So it's essentially saying, okay, given the encoding of this image and the encoding of its caption, conditioned on the encoding of its caption, reproduce the same latent representing that image. So, to me, it kind of made sense. And because of the way that this latent space is structured, because of the encoder-decoder pair, things that are visually similar tend to be close together. That's part of the effect of contrastive training. And so the thinking was, okay, well, kind of analogously, the loss for the training objective of this model would be minimized if for every caption it reproduced the corresponding image exactly every time. And so my kind of analogous thinking was, okay, well, if that were true, then we can say each generation of such a model would be as if it were an original data point in its latent space. But of course, those data points don't necessarily exist. So we say, okay, like where would that data point be? And that data point is like going to be weighted according to its neighbors. And I hesitate to say interpolate, because what people are going to do is like, you're going to be like, haha, I caught you out. You say models interpolate, but they don't really do that. That's not really what I mean. All I'm saying is that the corresponding data point would be in latent space. And then we can say, okay, here are the neighbors that you know would interpolate to it. And that's the starting point. And then we looked at, first of all, the fact that like, it's actually well known, there's plenty of literature around this, that duplicates in data sets tend to weight generations more heavily to be more perceptually similar. They are one of the main drivers of like models being able to exactly reproduce images from their training set. So we take that
something
into
like
account.
Lion, are they trying to scrub duplicates out?
Yeah, they have a project for that right now. I think there's a bunch of ways. I actually think that commercial deployments of latent diffusion models probably have already deduplicated their data sets, because I think the like cost reward is pretty good. Certainly OpenAI with DALI, they even put out it's not even a paper, it's a blog post called DALI pre-training mitigations, which explained how they deduplicated the data set because they found that it was regurgitating inputs. So Lion really want a cleaner data set. They're working on it. So that's the first thing we looked at. So we say, okay, well, when a generation ends up in this region of latent space where there's tons of duplicates of the same image, we'll collapse those duplicates and just weight them accordingly. And then we'll look at what else is like nearby. And it's a start that like, you can imagine this is like starting to warp the latent space that we're actually doing the similarity search in.
I think to like, for an idiot like me, and maybe people who aren't as deep in this, when you're like talking about seeing things kind of near each other in latent space and you're identifying them, like what's happening on your computer? What are you looking at? Like, what are you checking to make sure that this works or doesn't work? Like, take us behind the scenes of that piece a little bit.
So there's a thing called a vector database or vector index running on our machine. It has the encoding of the entire Lion 5B dataset inside it, represented as the vectors for the images. We also have encodings for some parts. Like we don't have all the text captions from Lion 5B encoded. We just haven't run that yet because it needs GPU where it gets expensive, so we didn't do it. And what you do is you basically query that vector database and you ask it for, okay, here's a new vector which may or may not already be in here. Can you tell me what the nearest neighbors are? There's two kinds of nearest neighbor. There's k nearest neighbor, which is giving you exactly the k nearest neighbors, right? It does exactly what it says in the box. But the problem with that is even the best KNN algorithms, exact KNN algorithms, scale linearly in the amount of data. So you can imagine like with 5 billion data points, you're in real trouble for every single query. Approximate nearest neighbor algorithms, of which there are a few, hierarchical nearest neighbor small world algorithms are like pretty state of the art. There's a bunch of stuff right now and there's increasing interest in this whole thing. Allow you to scale sublinearly. But it means that you won't get as like the results you get back won't necessarily be accurate. So it gives you approximate nearest neighbor, but it means that you're able to query very large data sets like that.
And what's the difference in cost between those two approaches?
I mean, the trade-off is accuracy. The trade-off is recall. You'll miss some points if you use approximate nearest neighbor, but you can tune for your specific data set and you can tune for your sort of query types as well.
Got it.
Yeah. So we do that. We grab the neighbors that they tell us, and we sort of take a look at, okay, well, what parts of the latents are actually important? Why do these seem like neighbors? And of course, we look at the corresponding images and we say, okay, well, do these kind of look similar? Why might these look similar? And there's this interesting problem, and it's a global problem, or it's a general problem in machine learning interpretability work, which is which is the models are pretty alien. Even if you're looking at something and it doesn't look at all the same, or it looks like pretty different to the model, those two things are very similar in some very specific sense, because the latent space of the model is nice and and continuous, and you can pick any point in it and you can decode that point and you will get something back. But the manifold of like human interpretability, which is like basically where this like surface where all the points should sit, is different to the one that the model comes up with. And so things that a human might not say are the same or similar, the model will as well. But that's like a common problem, interpretability. The model just perceives the world differently to how you do, because it's focused on different things. You've asked it to focus on different things. Classic problem. So yeah, that was our starting point. Just doing that. And again, we just used off the shelf open source software. We made sure that it ran like in our little cluster. We made sure that we could like query it remotely so that we could work on it as a team instead of just each of us having to have it on our individual machines, route queries, see what we were getting, automate a large part of this. We built a bunch of infrastructure out around it, which we hope to open source because it's pretty useful if you want to host one of these in the future. So we've got ways to like spin this up in a cluster now as opposed to just downloading the repo as it exists today and running it on your machine. Yeah, so that was the first step. We looked at like weighting stuff by duplicates to simplify the process. The other thing we noticed really early on, and a bunch of papers kind of confirm this idea, is a lot of the time the encoded representation of the image differs from the encoded representation of its caption. And of course, as a technicality, the encoding of images that the models uses is not the same space as the encoding of its text. That's because there's an additional projection step where they go to the same latent space. That's not actually what's happening in latent diffusion models, but to close approximation, this is an interesting thing to note. A lot of the time, there's actually quite big divergence between the image vector and the text vector, despite the fact that the encoding decoder model is this contrastively trained language image model. They should be as close as possible together. A lot of the time, they're pretty divergent. And we found that really interesting. And so we computed that divergence for a subset, what we found to be the most relevant subset, which was things with a relatively high aesthetic score, computed across that subset. And we thought, okay, this is also an interesting way to weight things. We should take a look and see how the results change. And we like the sort of trade-off we kind of intuitively make here is data points where the image and caption end up being very similar in their embedding are going to tell the model about specific things, and things that differ strongly from their caption and image help the model to generalize. And it's being treated almost like noise. And so because we wanted with the attribution algorithm to be able to say, okay, these images contributed in some sense, and we'll get to exactly what attribution and contribution means in a bit, we weighted things by that difference when it was available to us, when we had it computed. And that's all well and good.
And is that difference, is there a way to think about that in plain English, which is like, the image, if you like take it back out from latent space, the image is a picture of a cat holding a purple ball sitting on a couch, and the text is a cat sitting on a chair holding a red ball, like, but they should be similar, or can you not really translate to human?
There's a lot of reasons that happen. One of the reasons is the data set itself is noisy. So often the caption just simply doesn't match the image, as an example you gave there. But the mismatch is actually a lot worse than the one you just described. Like it might just be cool, awesome picture, something, 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 with no reference to what's actually in the image itself, right?
Yeah.
It's actually much worse than what you described. And so the idea is like when they're matching really well, that's going to help the model to reproduce more specifically, whereas if they're really not matching, that's not going to help the model generalize instead. It's going to be able to think about like broad ideas in the space of images, unassociated to text necessarily, and can learn like all kinds of structures that way. It's a hypothesis. We haven't tested it rigorously yet, but we would like to. So we weighted by like those differences, and images with better matching clip vectors are weighted more highly. And that's what we can do with the static data set. That's all stuff we could pre-compute. So that was nice. And the thing is like at every step of the way, we still get pretty unusual results. We get results that are perceptually strange to humans quite frequently, relatively frequently. But to the model, the principle, like the similarity principle, does apply. The next thing we did was like look at what we could do with the live model itself. And so we knew we would be getting these images after the fact. So, we couldn't look into the model while they were being generated, but there are things you can do to figure out, to like basically recreate the generation process for an input image. This process is called direct image text inversion, but it requires you to have the caption, which again, or a caption or a prompt in the case of generated images. We knew we wouldn't be able to get those most of the time. So because we wanted to see what the model does for a generated image, and these are, by the way, the more highly experimental features which go up and down all the time. This thing is held together by like tape and shoestrings and wood glue. So what we do is we create a caption. And from the papers that show, like duplication of the training set, we actually found that like the like associated caption, the model generated caption, is more likely to recreate the image than like the actual dataset caption for that image, which is interesting effect. Also not quite sure what it means. Worth more investigation in my opinion. Generate a caption, do this direct text image inversion, get the latent back, and then we can run the diffusion process forward again to see what specifically the attention mechanisms are doing at each step. And then using what the attention mechanism is doing, we can make a thing called an attention map. And what an attention map is basically a weighting over the latent vector that the model generates. And it says these parts of the latent vector are more important for what I generated. These are less important for what I generated. These are the things that come from generalization. And these are the things that come specifically because I'm trying to fit the prompt, is a way of looking at that.
Yeah.
And so, and what a weighting on a vector is, like, it's basically what's called a affine transform. You like rotate and stretch the vector. And yeah, you rotate and stretch the vector. And so that also allowed us to be like, okay, well, this is an additional computation we can apply to find things that are relevant to what the model generated. So like now, instead of computing the raw distances, what we're going to do is we're going to grab way more neighbors. And then we are going to transform that latent space using the affine transform that we got from the attention map. And then we're going to compute distances. And then we're going to weight the distances by the stuff we pre-computed from the training set. So yeah, that's the entire approach. Now,
before we get to objection, because we're gonna go to a lot of objections, but
oh yeah.
So in that process, the output, if you go to the website, is 7, 10, however many images that pop up once you drag and drop your image in. Is that the ones that have the highest weights, or like what is the final selection and like the cutoff on which ones you're including, which ones you aren't?
Yeah. I mean, we ultimately return a finite set of the best results, and the ones that are closest in our new distance metric are the ones that we return as higher. And again, like, you get unusual results because all these different steps are things that the model perceives, not things that humans perceive necessarily directly. And when you get down to like individual contributing elements, this becomes pretty obvious a lot of the time.
And it's interesting because I've done a bunch of these now, and you can't, in most of them, there's not one where it's like, oh yeah, like that's the one that it's like really, really looks like. When maybe there's different pieces from a bunch of it, and there's like the nose here or the color, and that's probably too human readable. But
I think that's good.
Yeah, so there's like clearly a bunch of pieces, but like it doesn't look like you just cut out. It's not like a mosaic where you just cut out like a bunch of different pieces. Like sometimes you're like, wow, it made some leaps here to kind of get to this final image from the set that we have there. When you're talking about the model kind of picking up different things than a human would, is that even like things that we have language to describe, or like that a normal art history major would understand, like shading, or is it like totally different?
I would suggest that for this approach, it's basically totally different and very difficult to make it human interpretable, but it does suggest the possibility of creating a model which does pull in influences in a way that a human would, which are more interpretable. There's probably a possibility to do that here. Diffusion is like this great little process because it's a dynamic process, and you can like step in and change what the model is doing at every step of that process. And things like cross-attention guidance do exactly that. Like, it recomputes the attention maps instead of the ones the model generates. It's on its own. It's like, no, stick this and reweight it the way you want. And so that gives the possibility of like making generations much more human interpretable, and also like making the space of encoded stuff more human interpretable are possible approaches in the future. What we're seeing now, again, is like, this is what the model sees for the approach that we're attempting to do.
Got it. So now we can get to the fun part. So as happens on the internet, I think the first like 50 quote tweets that I saw on your original tweet about this were like all positive and this is amazing and kind of the things that we had talked about before, which is wanting to give artists credit for the work that they've done. I think people picked up on the fact that this is an important step towards that. And then because it's the internet, you know, the comments, either replies or quote tweets or blog posts or whatever started coming through and picking apart either, you know, the technical approach. I know, you know, some people called you a liar. Like, what were people upset about and kind of what even did that feel like?
Yeah, let me get to the technical objections first. So I think people assumed that I was, or we were presenting this approach as the be all and end all, which it's not. This is an attempt. This is an attempt to demonstrate that this is a technically tractable problem. Now, we do know that there are, in principle, more optimal approaches for credit assignment for elements of a model's training set, right? And the way to really do this, if you had infinite compute and however much time you wanted for each of these, would be something like generate your image and then make sure that you had like the random seed and the caption, and then basically do what's called leave one out, which is retrain the model, leaving out the, you know, starting in like the closest things to latent space, leave that out, leave that out, leave that out, keep leaving stuff out until the generated image you got from this constantly iteratively retrained model differed sufficiently much under some sufficiently metric of sufficiently much. And this is why this is all human interpretable in the end, or like socially determined in the end. Like what attribution actually means is not a technical question, but you can use technology to help understand what you should do. And so, but this is obviously intractable because it would involve retraining Stable Diffusion thousands of times to like figure out attribution for every single generation.
I was going to say, is this something that like OpenAI or Stability AI has enough GPUs to do, or like there's not enough GPUs in the universe right now to do something like this?
I think there are enough GPUs on Earth to like try to do this, but I don't think it's like economically reasonable to do it.
Yeah.
And certainly like it depends on the rate at which you want to be able to do this. This takes a long time. Like you literally have to retrain the model the same way you trained it in the first place. Every time you have to recreate it exactly, except missing this element from its data set. And then you say, okay, well, this is like how much the image keeps changing from the thing that you originally generated. So you can say this is the contribution to the actual generation. And then there's the argument, okay, well, it's like it changed, but it changed into something else. Like, does that mean this has less attribution to those things? What does it actually mean? So it's like, even this is technically feasible, but even this has arguments against its validity as an approach to assigning attribution. And we figured like doing something's better than doing nothing. I think an interesting investigation here would be to play with this in a toy model setting where actually retraining it like many, many times is not as computationally expensive. And I think that actually if we could collect global information about people fine-tuning Stable Diffusion models, that's a very similar thing, basically. Like every time someone does a dream booth or something like that, if we could actually collect that information and watch the diffusion process, that would be really great research data. But I don't think anyone's recording that right now. So yeah, so like there's better approaches. Our approach is fundamentally limited. As I mentioned earlier, our approach takes into account the model's training objective, which is to minimize the distance between the encodings of the generated image and the training image. That takes into account the model's like ability to recreate images. It doesn't take into account the model's ability to generalize, which is also a significant contribution to how latent diffusion models work. It's important that they can generalize because that's how you're able to create images that don't exist. And this method that we've come up with, this sort of similarity scoring method, doesn't take into account generality directly anyway. I think that that's a really tough problem. But I think there's a really interesting case to be made to compare the two approaches, the very computationally intensive one and this one, which is, you know, similarity based, and empirically just take a look. Like, to what extent is this actually true? And in a toy model setting with enough compute, I think that can be done.
It's interesting. Yeah. It brings up a couple sets of questions. One, which is like, who's mad about, you know, the way that you all did it? And I guess a related question is kind of like, what is the purpose of this now and what is it in the future, right? Like if billions of dollars are on the line because artists are getting paid out automatically based on the fact that that Stable Attribution is identifying them as one of the artists who contributed to the work, then I can see like really needing to be very precise. If it's to draw awareness to this, to show that there's a solution, I can see doing this approach. So to you, kind of like, what is the goal today, and then what is the goal for something like this in the future?
Yeah, I think today the goal is to demonstrate that this is in principle possible. It's a tractable problem that we can make real progress on. And I think the response kind of demonstrates this is something that people sorely want. None of the responses have been like, oh, if this existed, we wouldn't care about it. All the responses have been, yeah, but this doesn't work, or it's not really doing what you say. Or I think our biggest objection, and I think this is actually kind of a little bit our fault, is like people, you can upload any image you want into Stable Attribution. We had thought that because the open source repo for Stable Diffusion contained the Stable Diffusion watermark, we would be all right by like detecting it. But we found that like in most publicly available hosted versions of Stable Diffusion, and probably because a lot of them run on Hugging Face transformers, that watermark isn't there, so we can't detect it. And so what ends up happening is people like upload an image of their cat or scribbles that they did in MS Paint, and then it's on our website with that framing of this AI generated image from these source images. That's probably that could have probably been handled better. We do like warn people, but there's a limited amount to what we can do, I feel.
Like if I upload my MS Paint, will it find the things that are kind of like most similar to my MS Paint, or that like would have contributed to it?
So it will do like the full model round trip. When it does a full round trip, it would be like, if Stable Diffusion had generated this MS Paint image, here's whatever, right?
Which is also kind of interesting. Like, it again, it's like a copy on the website issue, and
I think it's also a lot less stable. Like one of the things with like this image inversion thing is it works for generated images. I think it works. I haven't actually really looked into this. I need to, if we continue research in this direction. If you stick your MS Paint image in, and then we do the thing where we generate a caption and then invert it and then run diffusion forward, you probably, I want to say you probably won't get the same MS Paint image back. Interesting empirical experiment to do. Someone should do it. Someone with access to cheap compute ought to give that a shot and see what kind of results you get. But it's trying. Like the algorithm will always try. It will always try. We can't not make it try. We'll always try.
It's also amazing to me, like the watermark is one thing, but that like the thing that the model produces will be the same kind of like file format and put together. I mean, I guess it's all just pixels in the end, but like that it can't tell if this is AI generated or not AI generated.
There's research ongoing around this right now about detecting watermarks or detecting like common artifacts in generated images. I think it would be really nice if people just put watermarks in their hosted services. You can't stop people taking them out of like the open source repo, but if you have a hosted service, you might as well put a watermark in it and tell people what the watermark is. So there's like work effort out there to assign provenance to models. So someone DM'd me a really interesting paper. I haven't dug into it yet about it's actually possible apparently, or some researchers claim, to assign provenance to like know what model this came from. So I'd be interested in looking at that. I think there's another really interesting thing happened recently where, I don't know if you saw this, Scott Aronson, who's been working at OpenAI for the last little while, and there was actually some research which preempted them a little bit, which basically can like determine whether or not text is ChatGPT generated or GPT generated. And there might be a similar information theoretic approach here as well, although we haven't thought about that in much depth. I think like our goal here really was attribution.
I guess then the second part of the question is kind of just who gets upset that this is off, and who gets mad. What are the different sides of the debate here?
Yeah, there's like probably about three sides of the debate. The first side is people who basically either don't want to believe or can't believe this is possible, so they claim that the results are fake or that they don't make sense, instead of just kind of accepting in good faith that this has limitations and let's discuss those limitations, we can improve upon them. There are groups of people who worry about what impact this will have legally, which is really interesting. It's kind of like the future that I want to avoid, and the future that I think most people want to avoid is like Disney web crawling the entire web for images and being like, nope, that's generated using our IP. You need to take it down, whether or not it's actually generated using their IP. One of the reasons that we haven't actually opened the code is so that people don't do that. We're already facing things like people using this to claim that an artist's work was AI generated, for example. And that's, we definitely want to avoid that. It's not something we want. Seeing what the response would be in the wild was another reason for launching early, as opposed to like waiting until all the research was finally finished. So there's people, people are mad. And then there are people who attack the project on its technical merits. Again, I think we made engineering trade-offs. I don't think, like, we're definitely not out to deceive anybody. I've been very upfront about how this is supposed to work and how it works. But, people have, I think, expected us to launch only the most perfect version, when the reality is this will take a lot of research to get right. But I think it's important enough to do that research, and doing research in this direction is likely to improve our understanding of the training process of machine learning models, how they perform with respect to the training data. So
I'm picturing this group as kind of like the Hacker News commentariat. Or
I haven't actually read the Hacker News thread. We were #1 for roughly 24 hours, I think, which is great response. People care.
Yeah. Wait, how many people have been using it?
We had 52,000 uniques, I think. I think people have uploaded like probably 12,000 images.
Wow.
Haven't gone through all of them. I'm expecting to see pretty bad stuff in there, so I haven't really sat down and looked at what's gone through. I've been focused more on like clearing up a lot of the misconceptions here. This is an experiment that I think in the short term we'll continue to run, and then we'll decide what we want to do with it based on the response. And then we'll see what, if any of it, we want to, make open for other people to use. People have asked us for an API. Not sure we want to do that yet. We'll see. Because of course, like, this topic is controversial. There's concurrent lawsuits. One thing we did do, though, which I really want to emphasize, is we spent like a couple of weeks before launch, when it was clear that we were going to do this, talking to especially creatives and artists and getting their perspective on like what the real problem was and whether this tool was an approach that suited them. And the response there was positive, and that's another thing which pushed us to launch earlier rather than later. And it's actually kind of interesting.
Yeah, what was their feedback?
Yeah, I mean, they thought it was great. The kind of little intro animation you get at the start was based on feedback from artists or creatives who said, like, listen, a lot of people don't actually even know how this works or anything about it at all yet. So you need to educate a little bit. And so we had that graphic. And I think, yeah, like, they thought, okay, this is something that is a positive step forward. And then we sort of talked about like the good versions of the future that this could help build. And that's kind of another reason why we built this. Is there's the bad version where, copyright law is strengthened. Disney decides that every single character anyone might ever want to draw is actually a derivative work of a Disney character, and has these little scrapers that DMCA every image on the web, kind of like certain people have for YouTube. Don't want that at all. And we understand that people are threatened by that. But on the other perspective is, like, something like attribution can align incentives between the people who are actually creating the data and the point at which it's being like used to generate images. So I think you actually called this out. You said this changes these things into a distribution engine.
Yeah, I think it's fast. I mean, like, that's a weird kind of future-y one, I would imagine. But like, if there's somebody who is like, it's hard to even say their work is popular, right? But like, that enough people are asking for things similar to the kind of work that they do, but they're kind of obscure and posting in random places on the internet, they can actually be discovered. I think that's a really fascinating kind of potential outcome of this.
Yeah. And what's interesting? One of the things that we found from the dataset recreation papers is outliers also matter a lot. Outliers are points that the model tends to be good at, like, recreating, because that's the only thing it knows in that part of latent space. So it's like, well, I guess I'm just going to get this stuff. And that seems to override generality in the same way that weighting does, which is very interesting. But yeah, that's like, fascinating. As a search engine.
Yeah, in the post a couple weeks ago on differentiation, like, essentially part of my argument was like, you kind of just have to be as weird as humanly possible and like as different as humanly possible on things to stand out, or else, one, the AI can just like recreate average well, but you're also just like a more interesting input to the models if you're more different than anybody else.
Yeah, there's a few possible futures. So the search engine future, which you're talking about, I think is actually really cool. And the model for this kind of already exists. When DALL-E 2 dropped, Sam Altman generated a pair of sneakers, and then he found somebody to make the sneakers, and now he occasionally wears the sneakers. And then, the thing that we do is we find a lot of Etsy links, we find a lot of Shopify links. And it's like, well, cool. Imagine if this, like, you iteratively created a design that you liked, and then we showed you who could do that for you. That sounds pretty great. Or like who's making similar things with aesthetic choices that you might like. Or like you mentioned, discovering people. So besides the like compensation part of this, discoverability search, there's also a decentralization aspect to this as well. If you can do like provenance and ownership after attribution. For example, like one possible future is instead of having like big companies owning their generative models for the images they have rights to and then like fighting each other, instead there could be a model trained on a, let's say Creative Commons publicly available or even donated data set. And that would be a very bland vanilla type of model, probably. And then, through fine tuning, everybody could have their own generative model based on their art. It's like, okay, you like my art? Well, here's my generative model. Create more of it. Do it. Remix my art for me. And then you can imagine like artists algorithmically collaborating even in ways like you could say like, okay, well, I like this artist style and I like this artist style. I'll like bring them together and it's going to create new images. And then we have attribution back to it. So everybody in this chain is like working all towards the same objective. One other thing that I really want to bring up here or note is people say, oh, well, human artists go out and look at a lot of images and they don't attribute their inspiration. I don't know. I think a lot of artists do attribute their inspiration. Like, yeah, here are my favorite illustrators and painters. People talk about that all the time. But besides that, it's like, it's an age-old question. It's a question as old as at least the Industrial Revolution. Who owns the product of labor, the owner of the machine or the people who put in the work? I think this allows us to actually ask that question properly instead of just pretending there's not a problem here.
I mean, like the technical piece of this is obviously compelling and something that people are debating in a live way, but like the philosophical piece of it is equally as interesting, and having this option out there to at least begin that seems like a good thing to me. I like the versions of the future that you're talking about here. Like how much needs to happen, or like how much does the cost of GPUs need to come down, or do they need to get more accessible, or whatever, like to get to a version of the future where you feel confident enough having like an automated system doing a lot of this?
So either like GPU cost and compute comes down significantly for us to be able to do this at like retraining scale every single time, or we do research that allows us to approximate what we would get with that approach in a much less computationally intensive way. And I'm bullish on that second one. I think demand for GPUs is only going to rise in coming years, and it's probably going to outstrip, supply for a while. At least that's my gut instinct here. But other approaches, computationally efficient approaches, might be able to approximate that sufficiently well. And again, I got to stress this part. The notion of optimality is like ultimately under a human chosen measure. Like it's optimal in some human chosen sense. There is no objective attribution function, right? There is just some function that we perhaps could all agree, or most of us could agree, is sufficiently fair in the way that it determines attribution. And then we can automatically apply that function instead of having humans with subjective impressions, which might change also according to who they might be friends with, doing it for us, right? Like expert opinion, is this a derivative work or not? And even being able to describe under this measure, this work is a derivative of this to this degree, is a lever. It's a tool we can use. Technology is a tool. It doesn't have its own objective reality. It doesn't have its own like will, or it can't decide for us what we think is right or wrong.
Close to saying it doesn't have its own will. So it doesn't have its own will yet, but it can't decide. Well, I mean, one of the things that strikes me is like everything has a distance to everything, I would imagine, in the model. Or that some things that are just like completely left out and had no contribution at all, or do you have to just pick a cutoff point at some time, or else in this future where there's stable coins being sent, you're sending like 0.000000001 cents to an artist each time?
I think like that threshold would have to be determined. Or you could do it a little bit more probabilistically, which is my preferred approach, where you compute a probability distribution. You say, okay, well, this is in like the 10th percentile, probably, but this one is like in the 91st percentile over the entire thing. So that's an actually interesting point, right? Some of the objections that I've had to one vision of the future, where it's like you get paid, a fraction of the revenue of a generated image, is that Spotify does this. And Spotify, for example, or any music service, Spotify, the income that artists make on it is like heavily Pareto distributed. Like the top 1% of artists make 99% of the income, right? And then there's this long tail. But the difference between this and Spotify is exactly what you just described. Everything contributes to everything, which means, in some sense, the income distribution ought to be far more, like it should have a lower Gini coefficient, basically. It should be flatter. And that's interesting, because then it's like, if these models work better, suddenly everyone's income scales, it raises up. And that's really interesting. I think that's actually something fundamentally different here. And it's the ability to like.
That's so interesting, right? Because it's not people saying like, we love Taylor Swift, and then Taylor Swift getting the marketing dollars behind her, and whatever. It's just you asking for an image that you want, and the model going and picking the best, the images that make the most sense to contribute. Yeah. I hadn't thought about that piece. That's really interesting.
Yeah, I mean, again, just to make sure, because someone's going to jump on me saying this, the model is not doing collaging, it's not cutting and pasting stuff together, but it is in some sense reproducing information in its training data. That's the only place information for the model to use can come from. It doesn't come from the external world for now. I think that may change very soon. I've been seeing some very interesting stuff happening. But yeah, like this possible better outcome even from that perspective. But I'm sure people will find ways to sort of optimize that system in unexpected ways as well. Look, human economic activity is the real paperclip maximizer. We already have these, right?
Right. I mean, like every TikTok video ends up going to the same thing. Every Spotify song is now shorter than old songs, because that the YouTube videos go to the same length. I'm sure people will figure out a way to hack this system as well. But you're right; it probably isn't even as skewed a distribution.
It would be interesting to try. To your next question, which was like, how long do I think this will take to get right? I don't know, a while. I doubt, like, certainly I wouldn't put huge confidence behind using our current algorithm directly, although because attribution is a human-defined thing, you can just say, this is how we're attributing work in the training set. Take it or leave it, right? There's nothing wrong with doing that, because there's, again, it's like, what is correct attribution? There is, in some sense, an optimal approach here, which is really like, how much does one image influence the output of the training set? But you can also just say, yeah, this is how we're going to assign credit in our model, right? It's what we're going to do for now.
Yeah,
it's better than nothing. We have to find some way to do it. This is like reasonably principled. We might as well adopt it for now. It doesn't have to be the be all and end all for the entire future.
Where do you think the money that, like, assuming, and I know that there are different reasons besides economic, but just going down that thread a little bit, where does the money that ultimately pays the artists who get attribution come from? Is that games and movies and people paying for it? Like, is there going to be a pot of money here for people to get paid out from?
Well, we've seen that these models have commercial applications. I'm sure as they improve, they'll have even more commercial applications, and so people will pay for them because they're economically valuable. And then from that revenue, you can pay your contributors. And I think that's like, it's really interesting, because if we end up in a world where everyone who creates new images that people enjoy absolutely hates and will not contribute to generative AI, then the models are going to suck forever, right? Like, I think this is actually happening with like Lensa, where like there was this craze for AI avatars. It was really cool, but now it's like, it's a little bit dated already, because memes cycle very quickly.
Yeah.
Right. We talked about that last time. Memes cycle very quickly, and so the like corpus that you're like ingesting into your models and keeping them fresh and actually relevant to what's going on, and there's new world events, so you need to take all that into account. You want people to be aligned. You want people to want to contribute their imagery, and so like having a way forward where people want to do that is probably like a good future, a better future than one where these two things are at odds. And if people are like coerced one way or another, right? If there's decisions like, oh yeah, you have no right to like whatever you post on the web if it's going into a generative model, well, people are probably going to stop posting stuff on the web so much. On the other hand, if you have like this heavily coercive IP regime, which is like Disney's evil scraper spider robots telling you that your thing is a derivative work because it was generated by this model, blah, 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 take it down. Both of those really suck. The thing to do is like work on this problem, at least in my opinion.
So I guess to kind of end this, I mean, we've talked about this before. You run a company, Chroma, with Jeff, and I'm an investor in the company. And I guess with my investor hat on, like, one question is, how much longer are you working on this? Kind of like, what's next for it? How much time does it take? How related to Chroma is this? Is this just like your contribution to the world? Like, how do you think all this fits together?
Yeah, I think that's a really good question. The core technology for this existing stable attribution algorithm is based on core Chroma tech. This is stuff that we've been building out since we founded the company, and that's why we were able to develop it relatively quickly and be able to like do the algorithms that we needed to do to like recompute the latent space, etc. We had that basically ready to go, and we had the necessary experience to do it, so we did it. The timeline was able to be very short for that reason. Also, we launched it basically out of like, your other question is like why we did this, and
yeah,
I think a big part of it was like, okay, solving this problem requires technology that is well within Chroma's remit. So not only is it based on software we've already written, it's based on kind of our perspective on machine learning, which is you can understand, or you can work to understand models based on their training data. And so this is like an obvious thing for us to do from that perspective. We didn't necessarily have an idea about how to commercialize this immediately, but we felt that given where things were going, it was a good idea to launch it when we did. So yeah, so like we did it partly because we could and we were right place, right time, and partly because it's a demonstration of the things that we're thinking about. Partly because I think it's like important to show people that you can actually work to solve these problems instead of just ignoring them or assuming they'll never go away. So
yeah, and I mean, I guess also to the points that you were making about the different ways that this can go, it is certainly in Chroma's long-term interest to make sure that it goes in a way that is not just all lawsuits or all people keeping their content offline. Like, the more models there are out there and the more usage there is, the more opportunity there is for the company as well. So it's a cool way to contribute and also kind of shape your long-term future.
Yep. Yeah. And we're time boxing this as an experiment, I think, gauging the reaction, seeing like what parts of the tech work and which don't. All of that is valuable information for us for the future. And again, like, depending on the reaction, depending on what people seem to want to do with it, we'll open source it or not. We'll see.
I've had a lot of fun playing with it. It's been very cool to kind of like see the progress of the different versions and get to use it now. If you need any help at all dealing with the emotional side of getting trolled on the internet, I got you. I've had a lot of experience there,
fine.
But I think that, I think it's a good sign that there's both, kind of strong positive and negative reactions. It means that you're in the middle of something important right now. And it's been cool to watch also you just kind of explaining the technical pieces behind it. And we'll link to the Twitter thread, and I'm sure we probably throw it up in the video at some point, but we'll link to that. We'll link to the papers that you kind of referenced. It's a good learning moment, if nothing else.
Yeah. I mean, it's been really good. We got to flex a bunch of infrastructure muscle, which we wouldn't otherwise necessarily have at this stage yet. So like, we're very familiar with like cloud provisioning this kind of service now. For example, this is like super relevant to what we're doing next. You got that in our investor update. So I feel good that we did this. Basically, I feel like it was not like it was in the direction that we wanted to be going as Chroma.
Absolutely. Well, thank you, Anton.
Cool.
I think next time I'd love to talk more about embeddings. I think we just got on right after Jeff had sent a tweet about people not understanding embeddings. So I think perfect timing to cover those. So if there's a paper that
what is he posting? Jeff is like very online, but in a way that I'm not. And so everything that he posts is like extremely cryptic, and you have to like peel his tweets sometimes, whereas mine are like very straightforward. I found it. He is posting a manifesto. That's the first I'm hearing of this.
I thought he said he wasn't going to post the manifesto. He was just going to post that little cryptic thing.
I will avoid posting a giant Twitter thread. All right, great. Yeah. All right.
Perfect. All right. So next time we'll do embeddings. If there's a paper I should read, let me know, and we'll share it with everybody.
Cool.
Let's do it.
All right.
Good luck out there, Anton. Thank you.
Thanks, Packy. Bye-bye.